Today I'll be talking about gel electrophoresis, which is a type of way to identify DNA. Now, it mainly involves a gel-based agar, the gel-based agar cube that has wells within it, and it will be put in a little electrocurrent box with a negative charge on one side and a positive on the other. Now, in the gel, there will be wells. The wells are very useful because that is where you put your DNA samples in. And each well gets their own DNA sample. Um, so, fun fact about DNA is that DNA is negative, so it'll always be attracted to the positive. So you always start the wells on the negative side so that they can travel to the positive end of the electricity being run through the gel, the current that's being run through. Also, with DNA and gel electrophoresis, the bigger pieces of DNA will be more towards the negative side, whereas the smaller will travel much farther along and be closer to the positive side. That's how you can tell the difference in sizing of DNA. Now, gel electrophoresis is really interesting and really useful in the fact that you can use it to identify things like different forms of diseases and stuff based on the DNA, or if you have genetic diseases. So what'll usually happen is, let's say you have a genetic disease. They will take samples of your DNA along with the segments that may have the disease, and they will run it through the well. They will put, your DNA in the wells, and then they will put a control that has the disease in another well, and it'll be marked as control. Always mark your samples, always mark what is this. They'll mark it, and it will, they'll run it, and they'll also run a dye through it. They have to run a dye through it because DNA is not visible to human eye, and even with the DNA running through the thing, you still need markers, so the dye is very useful, and after you dye it, you'll put it under a sort of screen reader. Usually they're kind of like UV, and they'll help you see against the dye what and where the DNA has gone and how it's traveled. And so what you'll do is you'll compare the your test subject against the control and see, are there similarities? Is this section like the control? If so, then in that case, the person may have a genetic disorder, which is actually, it's pretty close to home for me because I just recently had testing like this done for cancer, which is part of the reason I was so interested in the subject. Another way to identify this, and I've actually done a few projects on it, I've done gel electrophoresis. It is such a fascinating tool, but it can also be terrifying because you have to get your DNA and all your samples in these very tiny wells, and you don't want to break them. But they're very hard to see, especially when you're blind like me. Like these glasses, not for show, but they can be rad. But it's very interesting, it's very fun, and it's very useful. You could use it to identify whether there is currently a spread of certain types of infections, especially if you're trying to see if there's an outbreak. Say you have all these patients with very similar symptoms, but you're not sure if they have the common cold or an outbreak of some really serious disease. You'll use gel electrophoresis to compare based off the illness that you're worried is outbreak. You have that as control, and then you compare all the other patients. You can also do this to figure out which patient, say if this is a highly mutating virus, you can usually use it to figure out which patient was the patient 0, because they'll have the closest to what you know the the virus to be like, and then you can figure out from there how things have variated. But it's very useful, and it's very interesting. So as I stated, DNA is negative, so it always go towards the positive side. That's why you have to start at the negative end, and the closer it is to the front, to the negative, the bigger the molecules are, which is very interesting. It's harder for it to travel through the gel. And it's just a very interesting tool.